Let's start with the basics of trigonometry. And these are very, very basics. In fact, please remember these. This is the most useful lecture because everything in trigonometry is built upon basics. I mean, every complex problem could be broken down to basics as such. So we'll start with something called angle. Angle is anything between two directions. Please remember, I'm not saying lines. I'm saying directions. So I have a line and I have another line. So there are two angles. One is this one. So one is this direction, this direction. One is this direction, this direction. This will come handy. Please remember this. Angle can be measured in two units. I mean, one unit is called degree. The other one is called radians. Right. So I would refer this to as rads in this lecture. So remember that 180 degrees is equal to pi radians. That's all. That's what you need to remember. So I can write 1 degree is equal to pi by 180 rads. If you want, let's say, 24 degrees to be converted, simply multiply it by 24 degrees. I'm leaving the algebra to you. I mean, considering that you guys are at this level. Now let's start with something called the basic identities. Again, it's a revision. So if I look at a right angle triangle, right, and there are two sides to it, A, B, C. You remember Pythagoras theorem, this is called perpendicular, this is base, this is hypotenuse, but then these are not fixed. They depend on the direct and from where you're looking at. If you're looking from here, then this is the base and this is the perpendicular. Anyways, so these three sides have a ratio. Now, ratio A by B is called 10. 10 of what? Angle between these two. 10 theta, x, y, z, whatever. Ratio B is to C is called cosine theta, and A is to C is called sine theta. These are some of the very basic ratios in the trigonometry. We have their reciprocals. The reciprocals are given here. If you see that 1 by 10 theta is cos theta, 1 by sine theta is cosec theta, and 1 by cos theta is sec theta. I don't have to get into details of this. These are connected, the sine theta and cos theta, they are connected by a very, very basic identity, which everybody knows. It's called sine square theta plus cos square theta is equal to 1. Nobody is going to ask you to, to show this or use it directly, but yes, this is the base of almost all the trigonometric problems. Someone might say that, look, I want you to evaluate this particular thing. Sine 4 theta plus cos to the 4 theta. Now, what is it? So if I could just write it like this, that this is sine square theta whole squared plus cos square theta whole squared. This looks like a squared plus b squared to b, which is nothing but a plus b whole squared minus 2ab. That's again, you must be good with algebra. So I can write it as sine square theta plus cos square theta whole squared minus 2 sine square theta and cos square theta. Now this becomes 1 minus this thing. So again, the point is that it's not about the complexity of a problem. It's about how you break it down to a simpler one. Again, this is 1 plus 10 square theta is equal to sec square theta. This you could just divide it by cos square theta or divide it by sine square theta. You will get these. The second thing I want to cover is the complementary angles or complementary ratios. What are complementary ratios? I can transform sine of x or sine of theta to cos theta, correct? And how do I do that? So remember, sine 90 minus theta is equal to cos theta. Here, again, these are covered in your 10th, 11th standard. I'm just trying to, give you a revision. And what we need to remember is there are four quadrants. You can write A, S, T, C. Abbreviation is yours. We remembered it from after school to college. What it says is everything here is positive, all. Only sine is positive, only tan is positive, and only cos is positive, rest are negative. So when I say sine 90 minus theta, so 90, something less than 90, so it has to be in the first quadrant, and at 90 and 270. Sine will change to cos, cos will change to sine, tan to cot, cot to tan. So this is very basic. There's something very peculiar. What happens if somebody says, what is cos, let's say 6 pi plus theta, and what is cos 5 pi plus theta? Why am I doing it? You'll just see. When I say cos 6 pi, just think of it as cos pi plus theta. Okay, cos pi plus theta would be 180 plus theta here. It has to be negative. No, you have to multiply 180 by 6. It will be what? 540 something. And always remember, whenever this number is even, it will fall either in the first quadrant or the fourth quadrant where cos is positive. So the answer will be cos theta. And whenever this is odd, 1, 3, 5, whatever, this will fall in this quadrant and this quadrant, and it will be negative minus cos theta. Again, please remember this is just, we are just trying to scratch the surface to refresh ourselves. Next, we could see some basic rules which is like always followed, which is sine of minus theta is equal to minus sine theta, right? And cos of minus theta is equal to cos theta. From these two, we can infer that tan theta, which is equal to sine by cos of angles, right? Negative of this should be equal to minus tan theta. Please remember this. This will come handy to you. Then there is something else I want to cover, which is what happens when you're given something like let me take an example of this. So suppose you're given a question which is sine 50 degrees. I'm not writing, please assume that unless specified, I mean unless I say it's radian, it is degree. Sine 50 minus sine 70 plus sine 10. No table on this, I mean the table that we know as such, it has, I mean, the value that you can remember, obviously, they will be values that you can remember. They would be in the range of 0 to 90, and you don't get 50 and 70 in the table. Just see this thing, sine A minus sine B. So it says sine A minus sine B is equal to sine 2 cos A plus B by 2 and sine A minus B by 2. So I can easily write it as 2 cos 50 plus 70 is 120 divided by 2 is 60. This is 60 into sine A minus B. 50 minus 70 is minus 20 by 2 is minus 10. So it'll be sine minus 10 plus sine 10. Now it's pretty simple that cos 60 is 1 by 2. So this is 2 into 1 by 2. I'll be left with minus sine 10. Remember, sine minus theta is minus sine theta plus sine 10, and it would be 0, right? Uh, let's take one more example, and the example is suppose somebody says that there is this equation sine squared theta plus sine squared pi by 3 plus theta plus sine squared pi by 3 minus theta, right? What do you do with this? Again, there is a identity, a formula which is all these formulas are result of basic identities. The formula says that sine a plus b is equal to sine a cos b plus cos a sine b. So do you spot some similarity? What is it that I'm trying to get at? I'm not going to touch this. This will remain as such. But this is basically, it means this, right? So I can write the inner term as sine pi by 3 cos theta plus cos pi by 3 sine theta squared. All right. Plus, again, this will be sine pi by 3 cos theta minus cos pi by 3 sine theta. All right. So I solving it. Okay, I won't leave it to you. I'll show you how it is solved. Sine pi by 3 sine 60 is root 3 by 2. And then I have cosine of theta plus this is pi by 3. Cos pi by 3 is 1 by 2 and sine theta, right? And these two terms will be squared plus sine pi by 3, again the same thing with a negative sign, root 3 by 2 cos theta minus 1 by 2 sine theta whole squared. Don't you think it's a plus b whole squared plus a minus b whole squared, right? And the terms will be cancelled, and what I'm going to get, it will be 2a squared plus b squared. This is what the result will be of this identity. So you can straightforward write it as this should be 2 uh, times, you square them, it will be 3 by 4 cos square theta plus 1 by 4 sine square theta, correct? When you multiply it inside, you get 3 by 2 and you get 1 by 2 sine square theta. And you have another plus sine square theta, right? So these two will become 3 by 2 sine square theta. These two will become 3 by 2 cos square theta. And the answer will be 3 by 2. This is again, this is basically on very basic identities. In the coming lectures, we will use a lot of this. My advice to you would be, please make sure that you take either the snapshot or you make sure that take a pen and paper and write these in on a separate piece of paper. You will not be rotting these or learning these. What you have to do is you have to attempt a lot of questions, and once you do that, my suggestion is 100 odd questions are enough for you to remember this. So I'll see you in the next class. Thank you.